Hello students, in this video we'll understand total internal reflection. So total internal reflection is actually a very important topic, even if we consider the boards, class 10th board or a class 12 board, and it is also important with respect to the entrance examination like NEET or IIT JEE. So in this video we'll understand total internal reflection. So reflection, I think so most of the students know what reflection is, that when a ray of light is strikes a surface, a shiny surface, it gets reflected back. But in total internal reflection, reflection takes place. It is reflection only, but in different way it takes place. So first of all, we'll understand the definition of the total internal reflection. You can see that it is written over here. So first we'll understand the definition properly. So we see that it is the phenomenon by which a ray of light reflects back into the same medium when it passes from an optically denser medium to an optically rarer medium at an angle of incidence greater than the critical angle of that medium. Now, what does this mean? That let us consider that a ray of light is passing from a denser medium to a rarer medium. Now, what we mean by a denser medium is that like water is an optically denser medium and air is an optically rarer medium. So now if we consider that if a ray of light passes from water to air and it strikes the surface of water at an angle greater than the critical angle of that medium, then it gets reflected back into the medium. Now I know that you must be a bit confused with this definition. So if we'll try to understand it through the diagrams, then we can easily understand it. Now I'll make you understand total internal reflection with the help of three diagrams. Now first diagram is pretty easy, I think so you all must be knowing, and we see that there are two mediums. First medium is N1 medium, that is denser medium. N1 is the refractive index of the first medium and N2 is the refractive index of the second medium. Now denser medium you can take it as water or glass, whatever you can take, and N2 medium, let us consider it as air. Okay, now you see that a ray of light incident on that interface between that denser and rarer medium. Now it gets reflected partially and it gets refracted also, refracted into the second medium. Now as you all must be knowing that when a ray of light goes from a denser medium to a rarer medium, it gets reflected away from the normal, refracted away from the normal. So you see that when this ray passes through the denser medium and it enters into a rarer medium, it gets refracted away from the normal, a bit angle. So you see that the angle theta 2, the refractive angle, is greater than the incident angle, that is theta 1. So now we'll go to the second medium. Now in that second diagram we'll understand the critical angle. Now critical angle is very important. Like if you understand the critical angle, I think so total internal reflection, it will be quite easy to understand. So in critical angle, what if I can say you the definition, that when the angle of incidence when a ray of light is passes through a denser medium and it gets refracted into the rarer medium at an angle of refraction 90 degree. That means suppose a ray of light is passing from a denser medium of refractive index N1 and it passes through, it gets refracted into the rarer medium with a refractive index of N2. So now if we consider that angle of incidence is theta 1, the ray of light gets refracted at an angle of 90 degree. That means the incident ray passes along the surface of the medium 1 and medium 2. So the angle of refraction is 90 degree. So critical, now this angle of incidence theta 1 is critical angle. So what we can say about critical angle, that critical angle is the angle of incidence in the denser medium for which angle of refraction in the rarer medium is 90 degree. So you understand critical angle. Now we'll go to the third diagram. You see in the third diagram, now it will be easy for you to understand. Now the same thing is happening. A ray of light is trying to pass from a denser medium to a rarer medium. So you see that the angle of incidence is theta 1. Now this theta 1 is greater than the critical angle of that medium. Now N1 is obviously this portion is the denser medium, N2 is the rarer medium. So the angle of incidence theta 1 is greater than the critical angle of that medium. Okay, so when this theta 1 strikes, when the ray of light strikes the surface, the denser surface, at an angle of incidence theta 1 which is greater than the critical angle, the ray of light gets totally internally reflected back into the same medium. You see, generally what happens is when a ray of light is incident on a surface, you see that the ray of light gets reflected partially and gets refracted partially. So you understand, so some energy is also always lost when a ray of light is reflected from a certain medium. Now why it is why the total internal reflection is very important, because the ray of light is 100% reflected back into the same medium. Now why does it happen that when a ray of light is incident on the surface at an angle that is greater than the critical angle, there is no portion of light that is refracted into the rarer medium. That means there is no percentage of light that is refracted. The whole 100% of the light is reflected back into the same medium. Now this phenomena is called total internal reflection. Now you can easily define the total internal reflection based on this diagram, that when a ray of light is incident on an interface between the denser medium to rarer medium at an angle of incidence that is greater than the critical angle, then the ray of light is totally reflected back into the same medium, denser medium. This phenomena is called total internal reflection. Now you can ask me, what is the advantage of total internal reflection? You must have seen that diamonds shine a lot. Now what a normal glass doesn't shine much, but a diamonds shine a lot. Now it doesn't mean that diamond itself shines when it is found from below the earth, it itself shines. No, it doesn't happen. It's really it doesn't shine very much at the beginning, but the persons, there are people who actually cuts them at such an angle that that angle of reflection, or you say the critical angle, is very less. That is, it is around 20 degree, or more properly to say it is 22 degree, 22 or 23 degree critical angle for the diamond. Now what happens is the diamonds are cut at various portions on their surface. So when a ray of light enters the diamond, then the ray of light gets refracted, reflected back into that same medium, that is into the diamond. That means the ray of light is not able to come out easily, because whenever it strikes the internal surface of that diamond surface, it gets reflected back into the same medium, and it doesn't get refracted out of the medium. So you see that almost under, definitely some energy must be lost in that, but almost you can say that 99% of that energy or the ray of light remains into the medium, that is the diamond. That's why you see that a lot of ray of light is into the, or remains into the diamond. That's why it shines a lot. And not only diamond, there are some other phenomena like mirage. These all, or when a ray of light passes through an optical fiber. These days you must be listening in the news that optical fibers are being, the companies are, or the industries are using optical fibers to transmit the different things. So why are they using optical fibers? Because they are also made in such a way that the whole light or the whole energy is reflected back into the medium. That means when from one point of the optical fiber to another point, when it passes, there is very less amount of energy lost. So you see that there's conservation of energy, a lot of conservation of energy in an optical fiber. So I think so you must have got some idea about the total internal reflection. Maybe I'll definitely take some videos in the again very soon. I'll make you understand what total internal reflection is more easily, and some other important topics also I will try to make you understand. So this is Physics by Gaurav. I hope you like this video, and if you like it, I think so you should share with your friends, family members, so that they can understand. And not only this video, the purpose of this video is not only for just for academic purposes, that if you are going to give boards exams or the entrance exams. No, this is also for a layman, a simple and average student, or just people just trying to understand physics, So it's not only that you have to share with your academic students, academic friends, but your friends or families, your students, those who are not into the study, so that they can enjoy physics. They can understand it in a more enjoyable way, rather than just enjoying or that mugging of the facts. So I'll see you in the next video. Thank you so much.